Hello everybody, I am Jayanta Basak. I am from Huawei Technologies India Private Limited, Cloud and AI branch. I like to present AI for storage. I thank SDC India, SNIA for giving me the opportunity to present, to talk about AI for storage. My talk is organized like this. First, I will mention the different topics or different types of AI that are being applied in various problems in academia and industry. Then I will show how these different types of AI are can be applied to in storage with certain examples in the storage domain, how they can be applied. I'll then show the industry landscape, a summarized version of the industry landscape where AI is being applied in the storage domain. I'll then show a summary of academic research that is happening. I primarily taken the 20 and 21 top conference papers, summarize them. Finally, I'll summarize the certain active research area where the research is going on in academia and industry, and I'll conclude my talk. So first, let us see what are the different types of AI. There are four buckets or four types of AI: descriptive, reactive, predictive, and prescriptive. Descriptive AI, which essentially describes the input space or event space appropriately such that further decisions can be made. So descriptive AI does not take any decision, but it appropriately describes the input space. So some of the techniques are feature selection, extraction, dimensionality reduction, clustering, linear, nonlinear projection, sampling, data mining, etc. Sometimes descriptive AI is also referred to as analytics. So, however, many complex techniques are there in descriptive AI to appropriately represent the input space for further decision making. Reactive AI. Reactive AI essentially reacts to the situation. Certain events have happened and it finds out what is the appropriate action to be taken in so that event either it can happen again or it does not happen, whatever. So the appropriate reaction mechanism. So classical example is reinforcement learning, where certain reward or punishment is given depending on what kind of action has been taken. So adaptive control, dynamical system, reinforcement learning, deep reinforcement learning, game theoretic formulation, mechanism design, these are all parts of reactive AI. In descriptive AI, there is visualization also. Reactive AI is a decision-making process where the decision has to be made in order to for a situation that has already happened, for an action that already has happened. Predictive AI. Predictive AI is also known as proactive AI or predictive AI, where the agent predicts what is going to happen. It does not say what action to be taken, but it predicts what is going to happen. So classification, function approximation, regression, adversarial learning, these are all predictive AI. A classic example is stock market prediction. Whether stock market is going to rise or fall, whether some stock price is going to rise or fall, that is within the purview of predictive AI. And the most general category is prescriptive AI. Prescriptive AI not only describes the event space, it also predicts what is going to happen, and then it reacts appropriately to chalk out a plan how to handle what is going to happen. So that is the prescriptive AI. In a given situation, what is the optimal action that is to be taken? That is the domain of prescriptive AI. Bidirectional entity recognition, search, online advertising, convex, non-convex, stochastic optimization, grain theoretic frameworks, constant satisfaction. These are all within the purview of prescriptive AI. Since prescriptive AI is very general, there is no single technique for a wide variety of problem. It is highly connected to the domain. Depending on the domain knowledge and domain representation and everything, the prescriptive AI techniques differ. In the advertisement space, there can be one type of prescriptive AI, whereas in the other type of space, the prescriptive AI can be completely different. So now let me go through the storage problem, how these four types of AI can be applied to storage problems. Descriptive AI in storage, system description and mining, and work description and mining. So system is the inside the storage system, and workload is the outside agent, outside the storage system. So can we describe the system appropriately? Can we describe the configuration of the system such that we can say that this particular configuration and this particular configuration are similar? What is the meaning of similarity? Or can we say that this particular configuration is good? What does it mean? Is it just listing of all parameters? That may not make sense, because some parameters may be highly insensitive. So how to find which are sensitive parameters? And is it necessary that only the list of sensitive parameters are important? Can we measure what is the similarity between two configurations? Two parameters may look like different, but they may be derive the similar performance. So are those two configurations similar? So this is not a simple question. This is a very deep question, that how to measure similarity between configuration. Is it possible to come up with a topological map to describe distribution of configuration parameters? Can we say that system was in this space of configuration and it has moved to this type of configuration over time because administrator have changed the parameters, or certain actions have been taken in the system? Similarly, workload description, how to describe a workload, what kind of parameters. Some parameters may not be useful for certain types of workload, and particularly for SSD or flash-based workload, there might be lot of difference, whether write heavy, read heavy, whether the workload is in the performance tier, whether the workload is in the capacity tier. So there are many factors in describing the workload. Is it possible to get a workload map to describe the workload distribution? How to define a workload mix that is running on the system? There may not be a single workload. There may be multiple workload that is run on a single configuration. How to describe the workload mix? That is a question. Similarly, a little bit easier problem is system health monitoring. Can we show the heat map? Can we visualize the heat map where the data is being accessed more frequently and where the data is being accessed less frequently? Then capacity headroom, performance headroom. These are some of the problems of descriptive AI in storage. Now let us go to the reactive AI. Reactive AI in storage is classic example is fault localization, automatic troubleshooting and root cause analysis, performance anomaly detection, event anomaly detection, identifying related event anomalies that have happened in the past, configuration anomaly detection from community of users or best practices, modeling inter relationship of events anomalies, performance anomalies, system configuration anomalies over time, whether given anomaly is actually related to certain anomaly in the past. That is I'm not talking about the future anomalies, but can we find a chain that the most recent anomaly is related to the past, these anomalies, because of this most recent anomaly happened, so that we can take appropriate action. That is the part of the reactive AI. Understanding the root cause and troubleshooting. These are some of the reactive AI problems. Similarly, fault correction is part of the reactive AI. Then predictive AI is performance prediction, fault prediction. These are the two major domains where predictive AI is being used. Predict the saturation point for new workloads, existing workload mix, predict IOPS, capacity trend, optimally size a storage system for required workload mix, then predict the changing behavior of workload characteristics for dynamic, unstable workload in the short term and long term. Cache prefetching. Cache prefetching is not only block, it can be file prefetching, it can be web caching and various other fields. So prefetching is a very, very important area. Cache replacement is again important. We may not go by simple LRU, LFU, or LRC. We may predict that this block or this file block may require maybe difficult but possible, but this file may not be required in future, and we replace that file. That is possible. So cache replacement. So fault prediction, disk failure prediction was a classical example of fault prediction earlier, sometime back when disks were being used. Now SSDs generally fail very rarely, so getting the field data may be a challenge, but SSD failure prediction is a very widely researched area. What is the behavior failure characteristics of SSDs, reliability prediction of SSDs, other events prediction. And finally, I will just go to the prescriptive AI. What are the prescriptive AI in storage? So prescriptive AI is system optimization. System optimization is a very, very general area, and for whether we can fine tune the system parameters to derive the maximum performance. So what is performance? That has to be defined in order to have the appropriate action. So there can be a lot of Pareto optimal solutions also. So do we need the minimum RPO? Do we need the minimum latency, or do we need the maximum throughput? All cannot be achieved at the same time. So the system optimization, second thing, which parameters are related to which objective? We have to understand. So if we change the parameter, how the system is going to behave. So it involves all the descriptive, predictive, reactive, all kinds of AI, and then come up with a particular plan that this is the optimization, and then fine tunes the parameters depending on the need. So the prescriptive system optimization is a very broad area, and many research work is going on in this domain. So related is performance improvement. Can we do caching policy orchestration? If we have a list of caching policies, say LRU, LFU, then ARC, and many other predictive caching, and many others, depending on a dynamic environment where the workload is changing, can we say that apply this policy or apply that policy in this particular phase of the workload? Can we apply certain AI principles in there? So that is the caching policy orchestration. Optimally place the workloads in different aggregates such that the resources are optimally used, volume movement. So resource utilization, how to optimally do the resource utilization. It is even for containers, we can think of such problems that not only the infrastructure, but even for containers where the storage, CPU, memory, and storage and network are involved, how to optimally use such resources. For virtual machines also the same thing, how to optimally use the resources so that the throttling is minimum, so that no workload is throttled, no workload is sacrificed. So tier the data optimally such that overall latency is minimized. So there are nowadays for HPC architectures have generally two-tier architecture. One is performance tier, NAS for NFS or NAS architecture, the performance tier, and the backend is the object tier, object store, which is the capacity tier. So now there is for example, OEKI, Kimulo, they are offering two-tier architecture. So how to judiciously move the data from performance tier to capacity tier and capacity tier to performance tier back, so that the performance is never compromised, and also it does not occupy the performance tier storage space unnecessarily when the data is not being used. So all these decisions has to be made through prescriptive AI. Then risk mitigation, find out optimal plan to mitigate risk. That is the domain of prescriptive AI. Now I'll show the industry landscape. Interestingly, these various AI techniques are being applied to various facets of problems. They are mainly classified into 5 buckets: intelligent operations and maintenance, intelligent data protection and security, intelligent data tiering, intelligent data insights, and intelligent data optimization. I'm coming back to these problems. So many companies were actively working in this space, starting from Huawei to NetApp, Pure, HP, Dell EMC, IBM, Hitachi Vantara. All of them are, and there are many other companies who are investing in this space. In fact, CAGR, if we just see the bottom right, that CAGR is estimated to be 30% year-on-year growth. It is predicted that till 2025, this trend will go, and maybe it can be more also. So we have analyzed all each bucket, what is the investment across the industry for these 5 buckets. And we observed that on an average, 25 to 30% year-on-year growth is happening in all these areas. In some areas it is more. So intelligent storage or AI-based storage have many advantages. AI-based storage, it is not storage for AI. I'm saying AI-based storage that improved top line, reduced bottom line, reduced RTO. The downtime is improving. Downtime is reducing basically. Better protection. We can make the RTO better for important data and for the data which are not being accessed frequently. Overall RPO is basically getting improved. Improved performance for various application requirements, improved data defense capability in storage infrastructure. So let us come back to the 5 buckets. 3 buckets are in the control plane and 2 buckets in the data plane. So intelligent operations and maintenance, which has, one can understand that intelligent fault detection, intelligent anomaly detection, intelligent self-healing, which is again, self-healing is kind of prescriptive or reactive. Intelligent self-healing is reactive. Intelligence prediction, capacity, performance, bandwidth, headroom. Then intelligent data protection and security is an important area which is in the control plane. I'm not talking about the data plane, where can we understand the security risks or data risks from the control plane, from the anomalous access pattern. Then data privacy, whether a certain anomalous data access is happening, or can we do the data access control. Intelligent replication backup, this kind of areas can be handle intelligent data protection and security, which is in the control plane. Then intelligent data tiering, intelligent data lifecycle management, intelligent data placement, that kind of area, intelligent data placement, so that performance is not compromised and data does not occupy unnecessary storage space in the performance tier. That kind of decision. It is not necessarily 2-tier. It can be more than 2-tier also. And in the data plane, intelligent data insights, that is very, very important area where metadata generation at the edge, compliance policy, governance policy, enforcement. So this is important because this makes the storage decision, whether the data will cross the boundary, what kind of action has to be taken. So whether data can be moved into cloud or it has to be stored in the on-premise. All these decision and those decision also guide the storage architecture, that how the architecture should be, how much data has to be there, and all these decisions have to be made. So intelligent data insights is another area which is very, very important. Intelligent data optimization. Intelligent data optimization is the multi-staging data depending on the data. This is data plane because depending on the data content, multi-staging data can be done. Intelligent data duplication, intelligent compression. So that kind of area is intelligent data optimization. So data tiering and data multi-staging data is different. Data tiering depends on the data access pattern, whereas depending on the content, we can just do the multi-staging data. So now I'll just show the academic research insights. There are more than 10, 15, there are very prominent papers that have appeared. In 2018, Learn Index have appeared, and that is being actively researched upon for file system design. And there are many areas, not many, there are certain significant areas where academic research is being conducted and top conferences publish those papers. So I'll summarize in the end that what are those areas. So these are some of the papers, and it is for sake of time, I cannot go through each of the paper content, but this describes that there are, starting from file system design to memory management, and all these areas are being handled using AI and machine learning. So these are some of the areas, active research areas in AI for storage, which is being conducted in academia highly, and as well as in the industry. Auto tuning the storage system parameters. This is a very important area, and academic research is very actively working on this. Also, companies like Google, Oracle, HP, they are working on this, how to auto tune the system parameters depending on the workload. What is the objective, or whether we have to improve the performance, we have to minimize the RPO, or what kind of objective is there. Then learning data structure or learn index, that is being applied in file system design. That is another important area. Optimization of tail latency, where people are using AI to understand each IO level latency from the traces of which IO is causing the larger tail latency, and can it be optimized depending on the environment. Caching policy orchestration is another area. Then AI/ML based memory management, write amplification reduction into log structure file system. Can we judiciously do the file system design so that write amplification reduction happens? So this kind of area is AI/ML based, and that is happening. So now I want to conclude my talk. Thank you. So please take a moment to read this session. Thank you.